So when I take a look at problem 1, the way I like to approach it, as you're learning this, eventually you'll get to the point where you can just do it really quickly. But if we want to be a little bit more methodical about it, I see that there's 1, 2, 3 carbons before I get to the parentheses. And so I just like, okay, 3 carbons, 1, 2, 3. Quick and easy. And then I just renumber. If that's carbon 1, that's carbon 2, that's carbon 3. I see in the condensed formula that carbon 3 only has 1 hydrogen attached to it, but 2 methyl groups. So I would just draw those 2 methyl groups right there. And there it is. We're done. To double check and triple check to see if you've done everything right, we see that there's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. If you have more or less of 12 hydrogens there, then you've done something wrong. Double check your carbon count. Okay, how many carbons do we have over here? We have 2, 3, 4, 5. We have 5 carbons. Do I have 5 carbons in my skeletal? Yes. So you just are always double checking. Double check yourself, especially if you have a little extra time on exams. If you're done, just go through. Any questions on that first problem? How I did that? Yeah.
Let's say it was a testing thing and you did write out like CH3 or you did draw the methyl group. Would it be kind of wrong?
Yes. Because I said draw a skeletal structure. I don't want it drawn out. Because that's what skeletal tells us, right? Just draw the sticks. And if you're like, yeah, I'm not going to follow instructions, I'm going to draw my atoms. Then you didn't follow instructions. Right? Skeletal means skeletal. Let's see here. Yeah, great question, because I've seen people do this. They go CH3, CH2, CH, CH3, CH3, and that's their answer for their skeletal structure. That's not skeletal. That's not even partial, really. No. Because I don't roll that way. Do what the question asks. Okay? Okay, question number 2. What would we do? I say 1, 2, 3, 4, right? Before I got to that parentheses there, so I'll just go 1, 2, 3, 4. There's our 4 carbons. So carbons 1, 2, 3, and 4. Now it shows carbon 1 has 3 hydrogens. Carbon 2 only has 1. And carbon 3 only has 1. Okay, so in order for that to still fulfill the octet rule, it has to have a double bond. Because if you didn't have that double bond there, and only 1 hydrogen attached to carbons 2 and 3, then you would have a positive charge. Because remember, in order for carbon to be neutral, it needs 4 bonds. And so now when you look at that zigzag, you see that there's 1 hydrogen, 1 hydrogen. Carbon 4 also has 1 hydrogen, but it's attached to 2 other methyls. So if we expand this out, we can see there's our 3 hydrogens, 1, 1, and 1. Now, if that's what you did on the test, I need you guys to clean it up, because I know you're doing this just to double check and triple check yourself. But I said skeletal structure. So you would just go like this. Okay, that would be your answer. If you have that on your paper on the exam, that's fine. As long as you're like, hey, this is my final answer. That's what I'm going to grade. Okay, now with organic chemistry and a lot of the problems that you see, don't get in the trap of only learning it in one direction. You have to do it in the opposite direction as well. So that's what you were seeing here. Here's our zigzag. Can you draw that in the condensed formula? And so you number it. We have 1, 2, 3, 4, 5, like so. And so I'm numbering those carbons there, but then I see this methyl right here. How do I put that in a condensed formula? Okay, that's where you have to put the parentheses. Okay, so you find the longest carbon chain typically, and then anything that's branching off of that longest carbon chain, we're going to put into parentheses. So we would start off with CH3, that's carbon 1. And then we have carbon 2, which is what? CH2. And then CH3 is what? A CH. Okay, now we're at a branch point, right? So we want to take care of that branch point now. So all we do is put that into parentheses and say what it is. It's just a CH3. So that's carbon 1, 2, 3. Now where's carbon 4 going to go? On the right side of the parentheses. And carbon 4 is a CH2. And what's attached to carbon 5? Or carbon 4 is attached to carbon 5, okay? And the way that you draw that is very, very important, okay? Now, I'm expanding that out a little bit. That's not what I want you to do. It's an aldehyde, right? That's what we see. How do you write aldehydes in condensed formulas? Okay, we could write it COH. Okay, no, that is an alcohol. Okay, the way that you do aldehydes is this way. A very subtle thing. That means two completely different functional groups. That is how you draw the aldehyde. If you want to draw an alcohol, then it would be OH. Okay, there's a major distinction there. So that's how you would draw that condensed formula for that molecule. Okay, I got 2 minutes here. So what is the hybridization state of this carbon that I'm pointing to? What are we supposed to do? How do we figure that out? Count how many bonds? What about lone pairs? Okay, so we want to count how many electron groups there are. So another way to figure that out is understanding that we have a formal charge of +1. So how many hydrogens are attached to this carbon right there? 2. How many hydrogens are attached to that carbon? 0. Okay, so we got to review formal charge and what that means. So there's 0 hydrogens on this carbon. So how many electron groups are around that carbon? 3 groups. So that makes that carbon sp2 hybridized. So when we come back on Thursday, formal charges are going to be what we are needing to learn. Okay?